In this video, we are going to create a simple scrapper using request and BeautifulSoup, and we will try to make it really fast. We will look at concepts such as multithreading, multiprocessing, and we will also see how it compares with Scrapy. So let's get started. So the first thing that I'm going to do is I'm going to build a very simple scrapper using request and BeautifulSoup. If you're already comfortable with request and BeautifulSoup, you can look at the markers in the description and jump to the next section where we start optimizing it. This is a page which contains a link of all these circulating currencies. So these are the currencies, and what we want to do is we want to get this page into the local disk, right? So what we are going to do is we are simply going to call request.get and we will supply this URL. So BeautifulSoup needs two things. Number one, it needs a string which contains the HTML, and number two, it needs the parser that we want to use. So I'm going to use LXML parser. The complete HTML string we can get from response.text. So these two things, and we will have a soup object. From the soup object, there are multiple methods which are available. Typically, you will see that find and find all, and all these methods are used. But what I'm going to do is I'm going to use a select methods. So these select and select one method, these methods can actually take CSS selectors. So I'm not going to spend much time on the selector and how I created these selectors. So basically this is the element. So I'm going to press Ctrl F and paste the selector right over here. So here on the bottom, you can see that this is the selector. So you can see that there are 262 items. So here is the count, 262 items. So let me save this selector in a local variable. You don't have to do it, but I'm doing it just for the convenience. And the select method is actually going to return all the matching elements in one list. So this will give me all link elements, right? So let me create one empty list here. And what I'm going to do is from a link element, this can be anything. If you want, you can put something like X, but I will recommend that you use easy to remember variable names, right? Best practices. So for each link element in this list, all link elements, I'm going to look for a link element dot get method. So this is going to be our link. But right now this link is relative, so we want to convert this into absolute link, okay? So this is where we are going to use URL join method. And from URL join, it needs two strings. Number one, what is your actual page URL? So this is this URL, right? So this is where we are actually containing the current page URL. So we can write it like that. And the second part it expects is what is the partial URL. So this is our partial URL. So what it is going to do is it is going to convert this into absolute URL. So now we can override this link, and this link can be appended to this list that we are building. So let's do this. Link.append. So actually it should be links. So link.append. This list can be returned from this function. So this is the simple function which is going to generate the links. So I'm going to collapse it now. Keep it out of the mind, out of the sight. Now this is the function that we are going to use to actually extract data from all these pages, right? So I'm going to call this, just for the lack of better word, let's call it fetch. And it will take one link at a time. We will use request.get and we will get the link, and it is going to give us response. So we will get the response, and we want to save this response to a file, right? So why I want to save this to a file? Because I want to mimic a real life scenario. In real life scenario, whenever you are running your web scraping projects, you have two places where you have a long running task. The number one is your get request. Okay. So there is this network delay. So in this line, we have network delay. So this is the first thing. I also want to introduce the disk writing time. So disk IO, input output, that is another one which takes a lot of time. Let's take a simple approach, and what we will do is we will simply dump all the contents to a local folder. Nothing fancy. That is not the objective. We just want to see that if there is a disk IO, then how we can optimize. So what we are going to do is we need to get the file name first. So if we look at this link, okay, so this is how the link is going to be. So from this link, what I can do is I can extract this last part, and we can use that as a file name, right? So what I'm going to do is link.split. A reminder that this is not the best practice, but I'm doing it just to get it done very quickly. Okay, and then I'm going to append a .html. So this is my file name, and I want all the file to be inside this output folder, and don't forget the /. Okay, so ideally you should be using the OS module and path.join function to create these actual file, but I'm just taking a shortcut. So what it is going to do, in the current folder it will look for output folder, and inside that it will take the last part of the URL. So it is going to take United States dollar in this particular case, and then it will append .html. So this is my file name. So I'm just keeping it very simple. And now what I'm going to do is I'm going to open this file name. Okay, in I can do a write mode or write binary. So just to make it more efficient, I'm going to do it write binary, and then f.write. Okay, now if I'm doing write binary, then I need the bytes. I cannot use response.text here, right? So what I'm going to do instead is response.content. So this response.content, this will give me the actual bytes. So very quickly we will be able to write all these bytes to this file name, and that's all we are going to do. This was not a good practice, right? So we should be using if name equals main. All right, so what we are going to do is, first of all, we are going to get all the links using this get links function. So this will get all the links, right? So this function is just one function call, and I'm not going to modify or touch it. So basically what we are going to do is we are going to run a loop. So for link in all the links, and then we are going to call this fetch method on all these link, right? And this is the part which is going to take a lot of time because we have 260 plus links to process. So this is the part that we want to optimize. So what I would like you to do is focus on this part for the rest of the video. So this is where all the optimizations will be done. All right. So before we can actually monitor how much time it is taking, so we need to import time module, right? So we are going to calculate the time. So first of all, we need the start time. So let's simply call time.time. So what it is going to do, it is going to return the current time in seconds, right? We are going to work with seconds. So this is the current time. And finally, we are going to write how much time it took. So I'm going to use \n just so that it is always printed on new line, and then \t so that it is printed after a tab character. So this is only for aesthetics, okay? Total time. And this is where what I'm going to do is I'm going to again call time.time minus start time. We are going to put one print here, okay? And I don't want to print a lot of text, so I'll just print a dot. Typically, you can see in the suggestion itself that whenever you print something, there will be one new line character which will be printed at the end. And I don't want to do that. I want to mark the end. So what I'm going to do now is I'm going to run this complete program, and now you will see the problem that I'm talking about. It is not printing anything, and it's going to take some time, and then it will dump all those dots immediately. So all right, so it just completed, and you can see that it took 125 seconds, right? So let's put a comment here. No optimization, this much time it took without any optimization. All right, so what I'm going to do now is we are going to start with the optimization. So this is going to be no optimization. So all the code will be available. You just have to check the links below the description. Now, so currently we are at 125.14 seconds. So what is the first phase of optimization? The first phase is going to be changing this function. So I'm going to delete few comments here, right? So let's keep it clean. So what I'm going to do now is whenever we are using request.get function, it initiates a new connection to the web server from the beginning. Every time you call this, it initiates the complete connection. And whenever you are connecting to a web server, there are a lot of things which go behind the scene, so they are not visible when we are working with one or two URLs or whenever we are looking at the browser. But if you want to get a lot of URLs from the same server, what we can do is, instead of using request, we can use sessions, right? So that is going to be the first optimization. So what we are going to do is, we are going to call a request module right here in the main module. Okay, in the main function we are going to call request.session. All right, and this session object, we are going to store it in a variable. So in the fetch function, we are going to modify so that this session is supplied. So of course we need to modify this fetch function. So we will also send s, and this one, let's make a copy. All right, comment it out, and instead of request, I'm just going to say s.get. So basically it is going to reuse the same session again and again. It is going to reuse the same session. Okay, so this is the only change that we are going to make: creating an instance of session, passing the same session to the fetch method every time, and instead of request.get, it will use the same session.get. Nothing else, just two lines of change. So let's see what is the time it takes this time. All right, so let's see. So by the way, we also need to fix that. Actually, let's go to the code, and what we are going to do is, we are going to pass this additional parameter flush, and we are going to set it to true. So let's come here, and it took 26 seconds, but it dumped all these dots at one single go. So what I'm going to do here is, I'm going to run this once again, and you will see the difference. So now it is printing all these dots one by one. So it's not keeping, so whenever you print something to the console, it is kept in a buffer, and then that buffer is printed to the console, and it is not in our manual control. So when you set flush equal to true, it is immediately flushed to the console. So it is useful in this kind of scenario. So as you can see that it took 24.10 seconds as opposed to the 125 seconds before any kind of optimization. So what we are going to do here is, we are going to make a copy of this, and this number, yeah, dismiss. So this number, what we are going to do is, we will paste it here. So this is using sessions. So far what we have understood is that you should be using session if you are processing lot of pages from the same website. Now what I'm going to do is, I'm going to change this back to the original one. All right, so we will be using request. We don't want to use this. And I'm going to show you a few other tricks. All right, so let's comment this out. Now what we are going to do is, we are going to make use of multiprocessing. And what is multiprocessing? So basically multiprocessing is, you can think about all the cores in your CPU. So let me show you on the console. So we can run either the Python, or I'm going to run IPython. So let's run IPython. All right, so clear everything. So what I'm going to do is, I'm going to import from multiprocessing. There is a module, and you don't need to install it. It is part of the standard library. So from multiprocessing, I'm going to import CPU count, right? And let's run a CPU count. So you can see that it is giving me the number 8. So basically I have 8 CPU, not 8 CPUs, but 8 core CPUs. What we can basically do is, we can create 8 different processes, right? So what we are going to do is we are going to create 8 different processes, and each process is going to run on different CPU. Doesn't require many change. So this is in multiprocessing. So we are just going to need the CPU count. So this is one thing. And the second thing that we need is pool. So we are going to create a pool of processes. And how do we, so we are going to make use of with keyword. And if we look at the hint, so basically we just need to provide that how many processes we want to create. So that will depend on the CPU count. So let's give this parameter, and CPU count is a function. So don't forget this opening and closing bracket. Okay. And let's call this P. Now what we are going to do is we have a function and we have a list of links. All right. So what we are going to do is we are going to call the map function. Now map function will take, of course, a self. Apart from self, it will take a function and it will take an iterable, right? So the function that we want to process is fetch. So just provide the name of the function. Don't call this function. Don't do that. So we just want to provide the name of the function. And the second is iterable. The list of the links that we have is here. So this is the links. So now we don't have a for loop. Instead of for loop, we have the map function. So this is all we need to do. So now what it is going to do, it is going to create 8 different processes, and it will be a pool of all those processes. And that pool will be mapped with this function and this link. So as soon as one process is done with one link, it will be provided the next one. So let's see how much difference does it make. So I'm going to exit, clear, and let's simply run the same code once again. And probably you can see, if I'm not fast forwarding it, so you can see that it is running much faster, and we should have a better time than 28 seconds that we had earlier. So see, earlier we had around 28 seconds and now we got 14 seconds. So let me copy this and let's put it here. So this is multiprocessing. The next thing that we are going to try is multi-threading. So in multi-threading, what happens is that we create a lot of threads. Okay, these threads can switch. So let's say we create 8 threads, similar to what we did in 8 process. So each process, when it is running, when it is waiting from the network to give a reply, it is just waiting. It's not doing anything. So it's still, there is a wait involved when you're working with a process. But when you're working with threads, you don't have to wait actually. The processor can switch from one thread to the other thread. Whatever is suited for your machine, that will be the best thing that it will be doing. It sounds very difficult, but the execution is very simple. And let's keep a copy of the same code, okay? And you will see that we have to make a very minimal change. So this was multiprocessing. Okay. So now let's go back, and here, let me commit it out, but leave it here. So instead of multiprocessing, there is one more module called concurrent dot futures. Okay. From this, I'm simply going to import thread pool executor. And what we have to do is only few changes. So instead of pool, we will use thread pool executor. And instead of this number 8 that we were providing as the number of process, here we are going to provide the max workers. Okay. So in case of threads, you are not bound with a number of cores or number of CPUs in your machine. You can choose any number that works best for you. So I'm starting with 8 just because we did the same thing, right? We had 8 processes. So let's compare 8 processes with 8 threads, okay? And there is no other change. We are still using the map function. We are still supplying the fetch function, and we are still supplying this iterable which contains all the links, okay? So no other change, very simple. Now let's run this and see how much time it takes. So it's running. Yeah, it's hard to say actually without, unless I see the numbers, but looks like it's more or less in the same range. Yeah, Yeah, it took 12.75 seconds. So it's little bit faster, but not very fast. But remember that I told you that we are not limited with the number of cores. So let's make it big. Let's make it 25. So we can go very high, right? So let's clear this. Remember that this took 12.75 seconds with 8 threads. This time we have 25. Let's see. Oh, now you can see that it is taking much faster. I'm not fast forwarding. And it took 4.29 seconds with 25 threads. What if I set it to 100? Remember that even though it will take, so it basically you can see that it took only 2.5 seconds with 100 threads. There are few things that you need to remember. Number one, as the parameter name suggests, it is max worker. It does not mean that it is actually going to create 100 threads. It can use up to 100 threads, right? This is the first thing. The second thing is higher number does not always mean faster time, because if I set it to 250, right? So if I remember, there was 260 URLs to be processed. So let's see what happens if we set 260. So you can see, I'm not fast forwarding it and I'm not editing the video right now. I'm not going to edit this part. And probably you can see that it is stuck. Right now it is stuck. So with 260 process, it is stuck. So why it is stuck? So probably the overhead of creating new threads was a little bit too much. So what I'm going to do is probably I'm going to kill this, okay? The number of threads that you should be using is something that you need to optimize based on the requirements, based on your current scenario and current machine. So this number needs to be tweaked, right? So this was all about optimizing the beautiful soup and request, right? There is one thing that I want to mention here, that we did all this and we tried to keep all the code very simple, right? We do not have multiple parameters here. We are not using sessions here. We are writing to different files. We are not writing to the same file. So there are a lot of places where things can go wrong. So unless you have a very good understanding of how threads work, you may actually end up doing something wrong. So this is an easy approach for easy scripts, but as your scripts get complicated, this is not the best approach for beginners at least. Now let's do the same thing using Scrapy, and this time remember that we are not going to do anything further optimization. So we are going to write a very standard Scrapy spider, right? So Scrapy gen spider currencies, and I'm just putting an X here. Just want to make sure. Yeah, so we have regular.py and currencies.py. Let me empty this output star. Yeah. All right. So now we have one spider here. Yeah, this is the spider. So I'm going to split them side by side, these two files. And what I'm going to do is I'm simply going to copy a lot of code here. So this get links code, let me just copy this and put it here. So this is my starting URL. So I'm just going to put it here in start URL. So just because, I've zoomed up a lot for the video, I can't see the whole URL. So I don't want to mess it up. So I've just created a simple variable and I want to use the same selector. So once this is processed, I will be in parse method. So I'll use the same selector. So I'm just copying this selector, putting it here. So if I just call response.css, pass in this selector, and if I just call get all, it is going to return all the elements. But what I want is actually the href. So what we are going to do instead is I'm going to chain the CSS selectors, okay? And here we are going to extract the href attribute and then get all, right? So this will give me all the links. Simple. So these are my all links and I can actually copy this entire loop. Okay, so let me make this little bit smaller. So I'll have to rename little bit. So for all the link, so this part I don't need. URL join, I will not use it, but instead I will use response.url join. So this is directly available and I don't have to return anything from this, okay? all a link in links. Yeah. So nothing complicated so far. There is one thing that we are going to do here, which is Scrapy specific. So here I am going to yield the scrapy.request. Okay. So this is my link. That is what I'm going to yield. And I need to provide a callback method. So this is going to be self dot, what do we want to call it? Parse link. Bad name. Yeah, but let it be like that. Okay. But of course we don't have it right now. So let's define it. So this method will take self and response. Okay. And here we are going to do exactly the same thing what we did here, fetch. So I'm just copying this here just for the time being, and I'll edit it out. So this response we already have available. File name is what we need to create, but instead of link, we will use response.url. So this response.url will give the current link, and then we are using the same logic. We are creating the output file. And the last thing that we want to do is we want to print the timer. But as you know that Scrapy spiders cannot be run directly. So what I'm going to do is I'm going to import one more module. So scrapper helper as sh. So if you look at scrapper helper, basically there is this run spider method. So it's simply importing time, and it's using crawler process and process.crawl. So it's a standard stuff. So it's just you can write all these things manually, or just be lazy like me and put it in scrapper helper. And outside this class, so I'm going to collapse this class sh.runSpider, and here you have to give the class name. Okay, from no, come on, import scrapper helper as sh. So if everything is okay, we should have something wonderful. So I'm again going to use Python 3 and what is currencies.py. Okay, and there is one more thing that I want to do. Scrapy by default is going to put a lot of things on the console, right? So I will add one more setting here. So I will use the custom settings attribute, and I'll change the log level, log_level, and this I'm going to set it to warnings only. So I don't want to print all the log. So let's print only warnings. Let's see. Okay, so we have a lot of warnings. Yeah, here this response.content. So here instead of response.content, it should be response.body, right? So here in case of Scrapy, you have response.text, which contains the text. Response.json contains JSON, and response.body contains the raw bytes. So that is what we need here. Okay, so let's come back, clear everything, and go. And the initial log will be printed unless it finds warning. And you can see that it took only 3.3 seconds. So it is not as fast as, spawning 100 threads, but it is very, very close actually, So if you're using request without optimization, it was taking around 120 seconds, and now we are getting 3.3 seconds. So still it is really fast. So moral of the story, Scrapy by design. So we did not do anything special. This is standard Scrapy spider. Scrapy by design is written in such a way that it is going to run the fastest. So in the description, you will see link to all the code. So that was all for this video. As you can see that there are ways to optimize your scrappers using multiprocessing, multi-threading sessions, or better yet, without worrying about anything, just use Scrapy. So that's all for today. I'll see you in the next one.